Hey, hi. Myself Hanuman. Hope you're doing good. If you're here for the first time, so I recently started the video series for machine learning and data science. So as part of this, till now I have covered various machine learning techniques and the data pre-processing techniques that we have to do to predict the data using the machine learning algorithms. Okay. So we haven't like so covered any algorithm till now. So all the previous videos talk about the different types of techniques that we have to do on the data pre-processing. So if you are interested for the data pre-processing techniques, please refer to my uh, previous videos. So today we'll try to predict the housing prices using the linear regression. That is the first algorithm we are going to use as part of the supervised learning. Okay. So till now, what we have done, we did like a lot of things like the data pre-processing and maybe like the data filling or maybe like the data deleting if it is outliers data, something like that. Okay. So if you see, uh, okay, the latest topic that we have covered is min-max scaler and the standard scaler. So once we scale the data, so it looks like this. So using the min-max scaler, then if we run like so the mdf dot correlation, so this one will give the relation between the relation between all the columns. Okay, so it explains the amount in rupees is like a little highly depending on the price. So that means like so whenever the amount the price goes up, this goes up, like so whenever the price goes down, and like so this goes down, something like this. So even the bathroom also is having a positive relation. That means like so whenever the price goes up, this might also go up, and the price goes down, the bathroom count will like so highly depending on this one as well. Okay. So this is little positive and like so negative. This means maybe like so the amount of the housing price doesn't matter on this furnishing. Okay. And this is also the transaction is also having like a little negative impact, and the location is also having like a little like negative impact. But like so we use all these parameters to calculate the to predict the housing price. Okay. So first, as part of this, like so what we'll do, like so we'll do couple of things. So what we are trying to do, so first we are trying to predict the housing prices based on the remaining parameters. Okay, so we'll split the remaining columns and um, the housing price, maybe like the price that we are calculating. Okay, so we'll split the data into two parts. So one is like so these will be the input parameters, and based on the input parameters, so we'll be like predicting the housing prices. So that means so I'm taking the x as the input data. Okay, so in this one like so I'm taking the data set as a mdf. Mdf is like the min max scalar data, so whatever that is like so, right, equals mdf dot drop. Okay, so we'll not use this one, we'll use the consider the x as all these columns. So that means like so we need to drop this column from the mdf data set. X of drop. Okay, so what is that like so amount in rupees? Okay, x is equal to 1, and the y like so the y x is the input data, and like so y we can consider it as the maybe the predictions are like the kind of output. Okay, so y is so these columns, so the amount in rupees. If we query for x now, so it will have only the price and bathrooms floor encoded and all these details. Okay, so price in rupees, bathrooms, and all these things. If we query for the data as y, so it will have only the data which is related to the amount in prices. Okay, so then as part of the like the pre-processing techniques, so we have covered one topic like the multi-collinearity. So multi-collinearity is So when you within your data, so if one parameter is depending on the other parameter, then that one we will call it as a multi-collinearity. Okay, so we'll calculate the multi-collinearity. So that means maybe like, so once we calculate, and like, so I'll explain you one more time like, so what is the multi-collinearity. So to calculate the multi-collinearity, right, so what we have to do is like, so we have to first like, so import the data frame. Okay, import the data frame equal to pd dot data frame. Okay, so the pd is like, so I think that we need to import, we need to use the pandas, import pandas as pd. Okay, so for now I'll remove this. So from this data frame, the x columns, so we are trying to calculate the multi-collinearity for the x columns. Like, so let me execute the x multi-collinearity. So we'll give the x at the end so that it will print. Okay, so multi-collinearity, like, so that means, so among these 5 or 6 columns, right, so if any of the two data, if any of the two columns are highly dependent, so we'll be able to calculate the dependency using the multi-collinearity. Okay, so after this, so what we have to do is like, so af data. Okay, so we have to calculate for every columns. Okay, for x, so then, okay, so we need to import this one. This one will be like coming from scikit-learn. Okay, so model selection transition from stats models. Like, so we'll be able, we can import the variance inflation factor. Okay, so we don't need these two for now. Okay, so now like, so let me print like, so what is this vf data, then I'll explain. So if we execute, okay, so if you see like, so the flow furnishing encoded and transaction encoded, like, so these two values are like, so almost equal. And if you see the prices and the bathroom is also like almost equal, maybe like, so it's almost equal. That means, so the price of rupees is depending on bathroom, or maybe like, so bathroom is the number of bathrooms is like depending on the price. So that means if one parameter goes up, the other one is also going up, and if one parameter goes down, maybe like, so if one of the value goes down, and this one also goes down. And in the same way, maybe like, so the furnishing and the transaction, so this one we will call it as a multi-collinearity. So what is the use of multi-collinearity? Like, so the x is actually having like, so the input parameters is having almost like the 6 columns, maybe like this 6 pieces of data, right? Price, bathroom, floor encoded, furnishing encoded, like this. So instead of like, see, using all the 6 fields, like, so we can use, we can find out like, so what is the multi-collinearity. So that means if the price and bathroom are almost like, so equal, so that means in any of these two, like, so we can use one as the input parameter, and among this maybe like the furnishing and the transaction can use one value as the input parameter. So instead of like, so using the 6 fields, like, so what we'll be like, so using is x equal to x of, so what are the columns that we are going to use? The prices instead of maybe like the bathrooms. If we want to use the bathrooms as well, maybe like, so we can use it. So for now, like, so maybe like, so I'll consider the bathroom as well like the input parameter. Okay. Or like, so since these two are highly dependent, like, so we can use only like, so one value. But yeah, like, so for now, like, so for calculations, like, so let me use both the fields. Okay, so floor encoded and then furnishing include. So among these, like, so I'll use like, so one value, maybe like, so I can use this one, or maybe like, so I can use this one. Like, so let me try to use this one, transaction included, right? Okay. So location encoded. Okay. So now, so earlier, so we were using the X as all the six columns: price, bathrooms, floor, furnishing, and transactions, and locations, right? So since these two, like the transaction and furnishing, are highly multi-coefficient, like, so multi-collinearity, so that's the reason, like, so we can use only one field. We can use one field among these two. Okay. So now if we see the X, maybe like, so we are not using the transaction, sorry, we are not using the furnishing, and like, so we are using only the transaction encoded, because like, so we can use any of these two. So here also, like, so we can use any of these two, but yeah, like, so I'm using both the fields for now. Like, so let me calculate the X. So if you print the X now, it will have, okay, so 5 fields, right? So then what we have to do, like, okay, so this is how we calculated the till now, like, so what we have done, like, so we considered these 6 fields as the input to predict the housing prices, amount, housing price. Okay. Among these 6 fields also, like, so we calculated, so which one is having multi-collinearity. So from them, like, so we reduce the columns, maybe like from 6 to 5. So if we want, like, so we can remove this one, the bathroom as well, because like the price in rupees, or maybe the bathroom, like, highly dependent. So that's the reason, like, so I can, like, so we, if you want, like, so we can remove it. For now, like, so I removed only one column instead of the two. Then, like, so what we'll do, like, so we'll split the data. Okay. So for supervised, like, so learning, so the data will have input and output data, right? So in that case, like, so we will be like using the supervised learning. So we will use the 80% of the data is for testing purpose, training purpose, okay, and 20% of the data we will use for testing purpose. Okay. So for that, like, so we'll split maybe like, so the data into two parts. One is the training data, and other one is the testing data. Okay. So to split it, X train comma X test, Y train comma Y test is something like this. Okay. So train test split. So maybe like, so we need to import this one as well, maybe from scikit-learn. Okay. So train test split and a linear regression as well. Maybe like, so for now we don't need it, but yeah, like, so we'll keep it like this. So in the, maybe in next 1 or 2 lines, we are going to use a linear regression to train the data, and maybe like, so to expect the data. Okay. Now if you see, so we splitted the data, the training data as the 80%, the testing size is like, so 20%, right? So 0.2 means 20%. X test, Y train, Y test. So let me do, okay. So X train dot shape. Okay. So let me print all these shapes. Okay. So the testing X train is having around like, so 1,30,000. This is 80% of the data, and X test is having around like, so 32,566. This is around 20% of the data. Okay. And Y train is also having the same number of data, and like, so Y test is also having around like, so 20%. So what we'll do, like, so now we will be like using the linear regression. Okay. So first, like, so we need to initialize linear regression. Then it's very simple, like, so okay, so model dot, so all what we have to do is like, so we need to pass the training data, and like, so then, so we need to pass the training data to train the model. So then, so what we have to do, model dot predict, okay, so X test. So we will assign some value to this one, Y prediction. Okay. So what we did, like, so we trained the data. Sorry, we trained the model here with X and Y. Okay. That means input data and output. Okay. Y output is like, so for these values, so this is the price, and for these values, like, so this is the one. So for 80% of the data we were using for the training purpose, and like, so based on 20% of the data, like, so we will be like using for the testing purpose. So model dot fit, that means like, so we were training the model with the training data and the test data, right? And then like, so we were using the test data and like, so getting the predictions. So we will see like how the model has been predicted. Okay, so let me print Y predictions, comma, Y test. So this is the predicted data, but yeah, this is the actual output, uh, which the original data. We'll see, like, so we'll try to compare these two things and see like, so which one is correct. Okay, so the first one is model predicted is 0.10, but yeah, like, so okay, so and but yeah, here like, so it's predicted as 0.16. Okay, so and like, so the for second value the actual value is 0.19, but here the model predicted as 0.22. So it's little near, but yeah, like, so it's not the exact value, right? So if you see the last value as well, the model is having the model predicted as 0.28 something, but yeah, like, so the actual the value, the testing data which we proposed is like, so 34.34 something like this. So it didn't predicted the exact values, but yeah, like, so it was the values are near. So to rank this the linear regression, so what we can do, like, so we can use a different mechanism to see like, so how well our the linear regression is performing based on our data. So further, like, so what we have to do, like, so we can, I'll write one more block of the code so to see how well the algorithm is performing. So from scikit-learn, like, so there are like, so couple of metrics that we can do. So R2 score and the mean squared error. So that means like, on average, like, so what is the error that we are getting on the data using the linear regression, and like, so the R2 score is like, so if you want to score something maybe like, so out of 100, so what is the score that the R2 is giving, so for our model predictions. Okay, so mean squared error equals, okay, mean squared error. Okay, so we need to pass like, so what is the actual testing data and what is the predicted data that used the model predicted data. And for R2 as well, like, so we need to pass what is the actual test data and like, so what is the model predicted value. So let me print MSE, comma, MSE and R2 is R2. So if I execute it, so the error, the average error is 0.09%, but yeah, like, so the model predicted is for 80% of the data, or maybe like, so almost like, so for around like, so 77.9, almost like, so 78%, the model predicted the correct values. Okay, so we can score it like this. So no algorithm will give the exact values of this one. Like, so since we are doing a predictions, so this algorithm is the linear regression is predicting up to the 80%, maybe like 78%. So when can like we consider the prediction is good, like, so that means like so if the prediction is around like so the R2 score is above 80%, then we can consider like so um, the model is predicting good on the data. If it is like so less than 50%, maybe like so, sorry, if it is less than 80% or maybe like so less than 50%, or okay, so we can consider like, the model is not accurately predicting the data. Okay, so then like so in that case, like so what we can do, like so we need to retry the same predictions, same housing predictions with different kinds of algorithms that are available for the supervised learning. So in the next video, I'll try to cover like so different set of algorithms which are like the which can be used for supervised learning. So hope you like this, and maybe like so thank you for watching, and stay tuned for like different set of algorithms which can be used for the supervised learning. Thank you.